Hi everyone. So today's lesson is about roots and radicals, and I'm reviewing a little bit that we did in class just to make sure everyone understood. So first of all, we needed to review the parts of a radical, and the number that is like inside that little V part of the radical, that's called the index, and I'm going to be referring to that a lot in the next coming weeks. That term that's under the radical sign is called the radicand. And both of those are going to become important because they're not going to look the exact same way they have when we've talked about square roots. Now, the one thing you need to know is that if an index isn't written, so if no index, it's assumed to be 2. Then it's 2. And you actually already know that because we've been working with like the square roots before. So the square root of 25, well, there is a hidden 2 right there. We just don't write it when we're talking about square roots. All right, so let's just understand what I mean and what things are going to look like. So 2 is a square root of 4 because 2 squared equals 4. So we would write that as the square root of 4, and we know that that equals 2. So where it gets funny is when we talk about higher roots. So 2 is a cube root of 8 because 2 cubed equals 8. So then we would write that as the cubed root of 8. Notice the index is 3. So the cubed root of 8 is 2. All right, we can also deal with fourth roots, okay? The fourth root of 81, 3 is the fourth root of 81 because 3 to the fourth equals 81, so we'd write that with an index of 4. The fourth root of 81 is equal to 3, which leads me to the definition for these radicals. B is the nth root. Yes, n, the nth root of a, because b to the n equals a, so therefore the nth root of a is equal to b. All right, so this is what I mean. I'm going to give you roots that we will have to evaluate without a calculator. So this is asking me what is the cubed root of 64. So you have to know your cubes. So 4 times 4 times 4 gives me 64, so the cubed root of 64 is 4. The fifth root of 32. So the fifth root of 32 is the number 2 because 2 to the fifth equals 32. The cubed root of 125, so I'm looking for the number that multiplied by itself 3 times gives me 125, so 5 cubed. So the cubed root of 125 is 5. All right, I'm going to show you how to work with these, but as I said in class, there are very important roots that you need to know. You may, if you didn't write them down in class, you may want to write them down now. And I'm going to expect you to spend time practicing. I'm going to keep reviewing them as much as possible so you know these numbers. Okay, so let's talk about what we do with these numbers. Well, we have to understand the concept of real root versus complex roots. And so when we're looking at a root of any kind, if the n or the index, if the index is odd and a is positive, okay, so meaning that number is positive, then it has one real root. Okay, one real root. If n is even and a is positive, then it's going to have 2 real roots, both the positive and the negative answer. Kind of like when we take the square root, okay? But if n is even, so if the index is even and a, that little a term is negative, like negative 81, up till the time, if we're talking about real roots, then there will be no real roots. Now, there will be complex roots, so maybe imaginary roots, because remember when we take the square root of a negative, we get imaginary numbers. This is that same idea. All right, so let's talk about roots a little more, just kind of as review. I want to make sure we know how do we determine how many real roots a polynomial has or how many roots it has. If I give you the polynomial y equals x cubed, well, I know that it has 3 roots. And if I think of the graph for a second, this graph actually squiggles through 0, and it only touches the x-axis one time. So that means it has 2 imaginary roots. And I said 2 imaginary roots, which are complex, because complex roots always come in pairs. All right, so when I talk about that, I just want to make sure you know that this is actually what can happen. If it's a degree 1 polynomial, it is going to have one root and it will be real. Those are linear equations, okay? Quadratic equations can either have 2 real roots or 2 complex roots, because if it has 2 real roots, then there's no more roots it can have. So if it has 1 imaginary, then it has to have 2 because, again, they come in pairs. So this is just kind of the different things that can happen. But when the degree is odd, we need to know there's at least 1 real root, and it is guaranteed. All right, so let's talk about what that means. The question could ask you, find all the real roots. So we have to look at the index. So if I'm going to find all the real roots, I know there's at least 1 if I take the cubed root of 64. The real root would be 4. All right, the cubed root of 8 over 27. I need to know my perfect cube. So the cubed root of 8 is 2. The cubed root of 27 is 3. So there's 1 real root. All right, now I'm looking at an index, the 4th root of 256. The root is even. The index is even, which means I'm going to have 2 real answers, so plus and minus 4, because 4 to the 4 is 256. All right, here's an even number. Under the radical is a negative number, so there's no real roots. Okay, all right. Got to be careful here because we really would love to cancel out the square and say this is -7, but it actually is the square root of 49, which means plus or minus 7 because there are 2 real roots. All right, now here's an odd index. An odd index and a negative number is allowed. It's going to have 1 real root, but it's going to be negative. Okay, so -3. All right, now I'm going to throw in the variable. All right, so when we deal with variables, we simplify the number as we always have. But then we deal with the variable. You're going to divide the variable by the index of the root. Your result, that number of that variable, will come outside the radical. Any remainders will stay inside. Now, there's going to be more on this later, but for now, they're all going to go in evenly. But if there are remainders, they stay under the radical. All right, so look at this one. The square root of 25x squared. Now, we're just trying to find each radical. We're simplifying, so we're not asking for all the real roots, okay? All right, so this would be 5. The index is 2, so I divide x squared by 2, and that gives me x. So 5x is my answer. Usually the square roots you really remember. All right, now here we go. So the cubed root of x cubed, y is 6. So I'm going to take x cubed. I'm going to divide 3 by the index of 3, and that gives me x to the 1. I'm going to take y to the 6. I'm going to divide 6 by 3, and that's going to give me y to the 2. They all come right out because there's an exact number of cubes in there, okay? All right, so this next one, the 4th root of 16, be really careful. This is not the square root. It is the 4th root. The 4th root of 16 is 2, and then p to the 4th divided by 4 gives me p. Q to the 8th divided by 4 gives me q squared. No more radical because they were all perfect 4th roots. All right, x to the 10th. 10 divided by 5 is 2, so x squared. Y to the 15th. 15 divided by 5 is y cubed. They are perfect 5th roots, so there's no more radical necessary. All right, a couple more. 16x to the 8th. All right, it's a square root, so we know the square root of 16 is 4. 8 divided by 2 gives me 4, so x to the 4th power. Again, perfect even numbers, perfect squares. All right, x to the 12th, the 4th root of x to the 12th. 12 divided by 4 gives me x cubed. 16 divided by 4 gives me y to the 4th. And then the last one, the cubed root of 27, y to the 6th. Okay, so the cubed root of 27 is 3. I take 6, divide by 3, and I get y squared. All right, so where can we use this concept? Well, you already have. You can use the nth root concept to solve problems, okay? We're going to find 2 real solutions of each equation. So the first thing I would do in this first one, even though there's a decimal, is I would isolate x squared, and I get 0.64. I take the square root of both sides, and I get x equals plus or minus 0.8. All right, 2 solutions, I got 2 real roots. All right, x to the 4th. That means I'm going to have 4 solutions. All right, well, let's see what happens. I take the 4th root of both sides. So the 4th root of x to the 4th is x. I get a plus or minus. The 4th root of 1 is 1. So my answer is plus or minus 1. Those are real solutions. That means that I'm going to have 2 imaginary solutions. Okay? And we're going to talk about that more later. All right, so we're going to stop there today. I do want you to take some time to make sure that you have looked over those 3rd, 4th, 5th, and 6th roots that we talked about. And we will be practicing this in our next class period. Have a great